Hello students, I am Dilipudani, Assistant Professor at LJ Institute of Engineering and Technology. In application of partial derivative, today's topic is method of Lagrange multipliers. So in this method, we will see how to find out the maximum or minimum value of a given function subjected to given condition. So let's start. So first of all, we will see the process how to find out the maximum or a minimum value of a given function subjected to given condition using method of Lagrange multiplier. So let function of xyz be a function of three variables x, y, z, and the variables be connected by the relation phi of xyz equals to 0. This is the function f of xyz which is to be maximized or minimized, and this is a given condition, that is phi of xyz equals to 0. Suppose we wish to find the values of x, y, z for which f of xyz is maximum or minimum. For this purpose, we construct an auxiliary equation, that is f of xyz plus lambda into phi of xyz, that is equals to capital F. Now say this is an equation number 1, where capital F is a Lagrange function and lambda is called undetermined multiplier. Differentiating equation 1 partially with respect to x, y, z and equating it to 0, we will get the values of x, y, z for which f of x, y, z has maximum or minimum value. Now we will see example related to this topic. And example number 1 is find the minimum values of x square y z cube subject to the condition 2x plus y plus 3z equals to a. And here is the solution. Let function of x, y, z, that is equals to x square y z cube. We have to find out the minimum value of this function. Now say this is equation number 1. 2x plus y plus 3z equals to a. This is a given condition. Here phi of x, y, z is 2x plus y plus 3z minus a. Consider the Lagrange function capital F, that is equals to x square y z cube plus lambda into bracket 2x plus y plus 3z minus a. Let the auxiliary equation be x square y z cube plus lambda into bracket 2x plus y plus 3z minus a equals to 0. Now say this is equation number 3. Now differentiating equation number 3 partially with respect to x. So we will keep y and z constant. So derivative of x square is 2x, y and z cube is constant, lambda will be as it is, derivative of 2x, 2 is constant and derivative of x is 1. Then after y, 3z and minus a are constant, so its derivative will be 0. So we have 2x y z cube plus 2 lambda equals to 0. Now we will divide the equation by 2, and from that we will find out the value of lambda, and lambda that is equals to minus xy z cube. Now say this is equation number 4. Now differentiating equation number 3 partially with respect to y. So we will keep x and z constant. So x square and z cube, that will be as it is, and derivative of y, that will be 1. Then after plus lambda, that will be as it is, and then after derivative of 2x will be 0, derivative of y is 1, and 1 into lambda, answer is lambda, and derivative of 3z minus a, that will be 0. Now from here we will find out the value of lambda, and lambda equals to minus x square z cube. Now say this is equation number 5. Now differentiating equation number 3 partially with respect to z. So we will keep x and y constant. So for the first term, x square y will be constant, and derivative of z cube, that is 3z square. Then after plus lambda will be as it is. Then after derivative of 2x is 0, derivative of y is 0, 3 will be as it is, derivative of z is 1. So 3 into 1, answer is 3, and into lambda, answer is 3 lambda, and derivative of minus a is 0. So we have 3x square yz square plus 3 lambda equals to 0. Now dividing this equation by 3, and we will find out lambda from here. So we have lambda equals to minus x square yz square. Now say this is equation number 6. From equations number 4, 5 and 6, we can say that x, y, z cube, that is equals to x square z cube, and that is equals to x square y z square. Now we will divide this expression by xz square. So we will be having yz equals to xz equals to xy. So if you will equate yz equals to xz, so we will be having y equals to x, and if you will equate xz equals to xy, so we will be having z equals to y. Here we have y equals to x and y equals to z. So we have x equals to y equals to z. So in the given condition, that is 2x plus y plus 3z equals to a, we will replace y by x and z by x. So by doing so, we will be having the values of x, y and z. So substituting y equals to z equals to x in equation number 2, that is the given condition, that is 2x plus y plus 3z equals to a. So 2x will be as it is, replacing y by x and replacing z by x, so we have 3x. So we have 2x plus x plus 3x equals to a, and 2x plus x plus 3x, answer is 6x. So we have 6x equals to a. So from here we have x equals to a by 6. But as we know that x equals to y equals to z, so we have y that is equals to a by 6 and z equals to a by 6. So minimum value of the given function x square by z cube, that is equals to replacing x by a by 6. So it will become a by 6 square, replacing y by a by 6. Then after replacing z by a by 6, so it will become a by 6 raised to 3. So this whole will become a by 6 the whole raised to 6. So this is the minimum value of the given function x square y z cube subjected to the condition 2x plus y plus 3z equals to a. So this was all about example number 1. Now we will see example number 2 related to this topic. And example number 2 is find the point on the plane x plus 2y plus 3z equals to 13 nearest to the point 1, 1, 1. So let's start. Let d be the distance from point 1, 1, 1 to any point x, y, z on the given plane. So if we minimize d, then x, y, z is the nearest point to 1, 1, 1. So first of all, we will apply the distance formula, and the distance formula d square, that will be x minus 1 the whole square plus y minus 1 the whole square plus z minus 1 the whole square. This is the distance formula. Now let f of x y z, that is equals to x minus 1 the whole square plus y minus 1 the whole square plus z minus 1 the whole square. And the condition is x plus 2y plus 3z equals to 13. So we have phi of x y z, that is equals to x plus 2y plus 3z minus 13. Now we will form Lagrange function. Consider the Lagrange function capital F, that is equals to x minus 1 the whole square plus y minus 1 the whole square plus z minus 1 the whole square plus lambda into condition, and that condition is x plus 2y plus 3z minus 13. So this is the required Lagrange function. Now we will differentiate this equation partially with respect to x, with respect to y, and with respect to z to find out the value of x, y, z on the given plane. Let the auxiliary equation be x minus 1 the whole square plus y minus 1 the whole square plus z minus 1 the whole square plus lambda into condition, and condition is x plus 2y plus 3z minus 13, and this is equals to 0. Now say this is equation number 3. Now we will find out the partial derivative of this equation with respect to x, y, and z. So first of all, differentiating equation 3 partially with respect to x. So derivative of x minus 1 the whole square according to the formula d by dx, x raised to n, that is equals to n x raised to n minus 1. It will be 2 times x minus 1. But in place of x we have x minus 1. So again we will differentiate partially x minus 1 with respect to x. And derivative of x is 1 and minus 1 is 0. And if you will multiply 2 times x minus 1 by 1, you will be getting the same term, that is 2 times x minus 1. And y and z are constant, so definitely derivative of y minus 1 the whole square and derivative of z minus 1 the whole square, that will be 0. Then after lambda will be as it is, derivative of x is 1, so lambda into 1, the result is lambda, and then after 2y, 3z and minus 13 are constant values, so its derivative will be 0. Now from this equation we will find out the value of x. So we have x equals to 2 minus lambda by 2. Now say this is equation number 4. Now we will differentiate this equation number 3 partially with respect to y. So x minus 1 the whole square is constant, so its derivative will be 0. Now similarly derivative of y minus 1 the whole square partially with respect to y. Right, so it will be 2 times y minus 1, and again derivative of y minus 1 partially with respect to y. So derivative of y is 1 and 1 is 0. So we will be having 2 times y minus 1, and derivative of z minus 1 the whole square will be 0. Then after lambda will be as it is, derivative of x is 0. Then after derivative of 2y, that is 2 into 1, so answer is 2, and 2 into lambda, answer is 2 lambda. Then after derivative of 3z and minus 13, that will be 0. Now from this equation we will find out the value of y. So y equals to 1 minus lambda. Now say this is equation number 5. Now differentiating equation 3 partially with respect to z. So derivative of z, x minus 1 the whole square will be 0, derivative of y minus 1 the whole square will be 0, and derivative of z minus 1 the whole square will be 2 times z minus 1. and multiplied by derivative of z minus 1. Derivative of z is 1 and minus 1 is 0. Then after 3 will be as it is, and then after derivative of x and 2y will be 0. 3 will be as it is, derivative of z is 1, so 3 into 1 answer is 3, so it will become 3 lambda, and then after derivative of minus 13 is 0. Now from this equation we will find out the value of z, and the value of z is 2 minus 3 lambda by 2. Now say this is equation number 6. Now putting the values of x, y, z from equation 4, 5 and 6 in equation number 2. So we have x plus 2y plus 3z equals to 13. This is the given condition, and in this condition or in this equation we will put down the values of x, y and z. Value of x is 2 minus lambda by 2. 2 will be as it is. Then after y is 1 minus lambda plus 3 will be as it is, and z is 2 minus 3 lambda by 2, that is equals to 13. Now we will simplify this equation. So multiplying this equation by 2, so we have 2 minus lambda plus 4 into bracket 1 minus lambda plus 3 into bracket 2 minus 3 lambda, and that is equals to, if you multiply 13 by 2, so it will become 26. Now we have to simplify this equation. So 2 minus lambda will be as it is, multiplying 1 minus lambda by 4, so we have 4 minus 4 lambda. Then after multiplying 2 minus 3 lambda by 3, so we have 6 minus 9 lambda, and that is equals to 26. Now we will simplify this expression. So it will be 12 minus 14 lambda equals to 26. Now from this equation we will find out the value of lambda. So lambda will be minus 1. Now from this value of lambda equals to minus 1, we will find out the value of x, y and z. And we have x equals to 2 minus lambda by 2. So putting the value of lambda equals to minus 1, so we have x equals to 3 by 2. Now similarly y equals to 1 minus lambda, replacing lambda by minus 1, so y equals to 1 minus minus 1, so it will be 1 plus 1, so value of y equals to 2. Now z equals to 2 minus 3 lambda by 2, replacing lambda by minus 1, so minus 3 into minus 1, that is plus 3, and plus 3 plus 2 answer is 5. 5 divided by 2, so value of z equals to 5 by 2. So these are the values of x, y, z. X is 3 by 2, y is 2, and z equals to 5 by 2. Thus the nearest point on the given plane to 1, 1, 1 is 3 by 2 to 5 by 2. So this was all about example number 2. So in this lecture we have discussed about Lagrange method, in which we discussed how to find out the maximum or minimum value of a given function subjected to given condition, and 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.